This is section 12.4.3, percentiles. A percentile is the percentage of items less than a particular item in a distribution. Percentiles are based off of a data item's z-score, which we learned to calculate in the previous lesson. In order to find the percentile, we use this table. This can be found in your book on page 672. In this table, you will notice two columns. Down the left column, which you see here, is the z-score. Down the right column is the corresponding percentile. So to calculate percentile, you first need to calculate the z-score, then find the z-score in the table, and find the corresponding percentile. For example, let's say we calculated a z-score of 0.6. Well, we would have to look at the table and find the z-score of 0.6. You can see the z-scores start at -4, and they go all the way through to +4. 0.6 as a z-score occurs right here. The corresponding percentile is 72.57%. That means that whatever data item you use to get the z-score of 0.6, 72.57% of the data is less than that data item. Let's look at some examples. A student scores in the 62nd percentile on the SAT. What does that mean? Well, if a student scores in the 62nd percentile, that means that 62% of the people that took the SAT at that time scored less than this student. Let's look at the second example. The distribution of heights of young women is approximately normal, with a mean of 65 inches and a standard deviation of 2.5 inches. What percentage of young women are shorter than 68 inches? Now, when reading this problem, you need to note a couple very important things. First of all, they're telling us that the distribution of height is normally distributed. And they're asking what percentage of young women are shorter than 68 inches. Well, shorter means less than. We're looking for a percentile. So the first step is to calculate the z-score. We know that the z-score is the data item, which in this case is 68 inches, minus the mean, 65, divided by the standard deviation. In this problem, we get a z-score of 1.2. Now we need to go back to our table. And we need to find the z-score of 1.2. Looking through the column of z-scores, we see the z-score of 1.2 right here, and the corresponding percentile of 88.49. That means that 88.49% of young women are shorter than 68 inches. Let's look at another type of example. The Wechsler Adult Intelligence Scale is an IQ test. Scores on this scale for ages 20 to 34 are normally distributed with a mean of 110 and a standard deviation of 25. What percentage of IQ scores for this age group are greater than 145? Now, first thing we need to note is that we are being told that this data is normally distributed. Next thing is we are being asked to find the percentage of IQ scores that are greater than 145. So this is not a percentile because it's greater than. However, we will use percentiles to answer the question. So, first step, calculate the z-score. Data item minus the mean divided by the standard deviation. Gets us a z-score of 1.4. If we go back to our table and we look for the z-score of 1.4, right there, the percentile is 91.92. Now we know the percentile means less than. We don't want less than in this problem, we want greater than. So what we're going to do is we're going to take 100% minus the 91.92, and we're going to get the percentage greater than, which in this case is 8.08% of IQ scores are greater than 145. And let's look at our final example. The distribution of heights of young men is approximately normal, with a mean of 70 inches and a standard deviation of 2.5 inches. What percent of young men have heights between 67 inches and 74 inches? So again, we're being told that this distribution is approximately normal. And we're being asked to find the percentage of young men that have heights between 67 inches and 74 inches. Again, this is not the percentile, but we'll use the percentiles to find the answer to this question. Now, since we're finding the percentage between, here's what we're going to do. We're going to calculate the z-score for both data items, 67 and 74. Let's do that first. 67 minus the mean divided by the standard deviation gives us a z-score of negative 1.2. Next, calculate the z-score of the other data item, 74 minus 70 divided by 2.5 gives us a z-score of 1.6. Now, if we go to the table, we find the z-score of negative 1.2. Here it is. And the percentile of 11.51. So we have 11.51 is the percentile. Go to back to the table, find the z-score of 1.6. There it is. Percentile of 94.52. 94.52. So, if we want to find the percent of young men that have heights between 67 inches and 74 inches, what we're going to do is we're going to take 94.52 and subtract 11.51, and that'll give us the percentage between those two heights. So in this case, we get 83.01% of young men have a height between 67 and 74 inches. So in this video, we've covered three different types of problems. We've covered the example where we're looking for women that are shorter than, in which case we use the percentile to answer the question. Then we covered the example in which case we're looking for an IQ greater than, in which case we take 100% minus the percentile to get our answer. And then finally, the example where we're finding the percentage between two data items, in which case we find the two percentiles and the difference between them is our answer. This has been section 12.4.3 on percentiles.